A very good morning to all. Today I am going to discuss about the classification of electrical elements. Let's see one by one. First, what is meant by linear and non-linear elements? Linear and non-linear elements. This is regarding electrical. Electrically, what is meant by linear and non-linear elements? Consider a resistor. Suppose this is a resistor of resistance R ohm. Suppose we are passing a voltage through it and there will be a flow of current. Suppose we plot a graph between voltage and current, V and I graph, then we will obtain a graph like this. That means it is a graph of a linear, it is a straight line and passing through origin. So this is called the linear element, which show the linear characteristics. So resistance is a linear element which shows the linear characteristics. And suppose any element which doesn't follow these characteristics, which is known as the non-linear element. For example, diode. You may see that in a diode, suppose we are giving an alternating current or DC current through a diode, what happens? It will conduct for certain region and it will not conduct for certain region. We already know that for forward biasing it is conducting and forward reverse biasing it is not conducting. So suppose we take the voltage current characteristics of a diode, then what will be obtained? Suppose this is V and this is I graph of a diode, then it will be similar, it will be like this, and in reverse manner also like this, which means the diode characteristics is not a linear. So this is the difference between linear and non-linear characteristics. So linear means which follow the straight line, that is voltage and current relationship is in straight line manner and definitely it will be passing through the origin. That is called the linear characteristics, and those elements which satisfy this graph, voltage and current will be a straight line, relationship will be a straight line and passing through origin is called the linear elements. Clear? So resistor is a linear element but diode is a non-linear element. This is the characteristics of a diode. So diode is a non-linear element, transistor is a non-linear element, MOSFET, JFET, we will study later. All these power electronics devices all are non-linear. So this is the concept of linear and non-linear element. And let's see another classification which is called active and passive elements. Active and passive elements. Active elements means an element which can produce energy, which can be a source of voltage or current is called the active element. For example, suppose we dealing with the transistors. Transistor is an active element because suppose we are giving a small input to its base junction, then there will be an amplified version in the output terminal, so in the collector terminal. So this is our transistor, our transistor is collector and emitter. Our transistor will be an active element. Similarly, what is meant by passive element? Passive element means the elements those consume energy is called the passive element. For example, a resistor is a passive element because it consumes energy, it absorbs energy. Inductor is a passive element, capacitor is a passive element. So R and C and L all are what? Under the category of passive elements. And by observing the graph between voltage and current, how can we identify it is a passive or active? Let's see. Let's see. By observing the graph, we can say that it is active or passive. Suppose this is the voltage and current relationship for a resistance. For a resistor. Suppose the graph is like this. You imagine the graph is like this. So how can we say that this is either active or passive element? For checking that, we simply multiply V into I. We simply multiply V into I. That is voltage and current value. See, simply multiply. Suppose it is positive, then it is passive. And suppose V into I, the product of V into I is negative, then it is active. This is the trick to find whether, from graph of, generally in examination, we won't give directly the elements, but instead of that we will give the graph. So from this graph we can find it is active or passive like this. V into I positive for passive and V into I negative for active. So here we can see that either this, suppose consider this point. So the product of I and the product of V will be again positive because it is negative and it is negative. Again it is positive and it is positive. So the product will be again positive. So at any point of this graph, we will get the product of V and I as positive. So this is an example of passive. Of course, this will be the characteristics of resistor. So the resistor is a passive element. But suppose sometime V into I will be negative, it is called the active element. So active elements are, we can say, voltage source, current source, generator, all are the examples of what? Active elements, which means which is producing energy, which is producing V or I is called the what? Active elements. So is it clear? Okay. Let's move on to another classification. That is, another classification of elements is unilateral or bilateral elements. Unilateral or bilateral elements. First we can see what is unilateral. Okay, let's see first bilateral. Bilateral. Consider a circuit this is V, this is plus and this is minus, this is R, and there will be a flow of I through the circuit. So of course in this circuit, suppose we are assuming certain values of R, say it will be 5 ohm and suppose we assume this voltage as say 200 ohm, so this 200 volt, then what will be the value of current here? So I will be definitely I is equal to V by R, which is equal to 200 divided by 5, so which is nothing but 40 ampere. 40 ampere. So in next circuit, what I am going to change is simply this is R. I am changing the polarity like this. I am changing the polarity like this so that the current will be in this direction. The current will be in this direction. Same 200 volt, 5 ohm. Here also, what is the value of current I? Here also I is equal to what? 200 divided by again 5, which is equal to 40 ampere, no change. Which means bilateral circuit means even if we change the direction of current, direction, polarity of source, voltage source, the direction of current is changing, but the value of the current will be same. That means the resistor can behave in same manner for the positive, I mean this polarity, and for this polarity. I mean polarity changing, or we can say the direction of current in that element doesn't affect its property. I mean suppose we are sending some current through this element, or in either direction, it won't alter its property. Its property is what? Simply suppose generating heat, it is the property, you assume generation of heat is the property of resistor. It won't affect the property of the element, which is called the bilateral. That means in either direction it behaves like same. It's behave like same. So that is called the bilateral element. Then what will be unilateral? Let's see. Next we have to see unilateral. Unilateral. What is meant by unilateral element? Consider the case of a diode. D is the diode. I am applying a voltage like this, V, this is plus and this is minus. Then of course there will be a current I through this diode. Then that I will be some certain value. We assume definitely there will be an internal resistance of the diode. So it consumes some amount of energy through that internal resistance. Anyway, there will be a flow of current I. In this case, we can say that the diode is forward biased, right? The diode is forward biased. Consider another case in which the diode is same like this, but I am reversing the polarity. Then what happens? There will not be this is negative and this is positive. So positive is connected to negative terminal, I mean N, this is PN junction and this is PN junction. So positive is connected to N and negative is connected to P, so that the diode will be reverse biased. Means the diode is not at all conducting. It is like an open circuit and it is like a short circuit. Ideally, I am assuming it is an ideal diode. So in these two cases, what is happening here? In this polarity, I mean in forward direction, this polarity, there is a flow of current, but in this polarity, there is not at all a flow of current. That means the change in polarity affecting the property of the element, that is the diode. So the polarity change, if the polarity change affect the property of element, polarity change, in other words, the direction of current, this is in this direction, and suppose this is assumed to flow in this direction. So the direction of current is reversed, will affecting the nature or will affecting the behavior of element, then that type of element will be called it as unilateral. Unilateral means it is in one direction only. It can conduct or it behave in certain manner in one direction, it behave in certain manner for other direction. That means its behavior or its characteristics will be changing in accordance with the direction of current. That is called the unilateral. That means in one direction it is in one characteristics and in other direction it is in another characteristics. That is called the unilateral. So that is clearly from this graph now. For an ideal diode, the graph will be like this, but there will not be any current flow in reverse direction. So this will be the VI characteristics of a diode. This will be I and this will be V for ideal diode. I am assuming this as an ideal diode. So this is called the unilateral circuit. That means for one direction it's behave like something, and in another direction its behavior will be in different manner. That is called the unilateral. Clear? So we now we dealt about what active or passive, linear or non-linear, and unilateral and bilateral circuit. So definitely in examination this won't be asked directly, that is what do you mean by unilateral, or give an example of unilateral and bilateral. Maybe it asks, but we give more importance to graphs. by looking into the graphs, we have to identify what is it actually. I mean, in examination, you may give like this. You may give like this. Suppose this is the VI graph of a certain element. Say the element is X. We don't know the element value or the element nature. We have to say whether it is active or passive, unilateral or bilateral, and one more thing, linear or non-linear. So simply by looking into the graph, we have to say all this. That is our that is we are expecting in our examination. Let's see. By looking at the graph, how can we say it is active or passive element? I already say the product of V into I. Take the product of V into I at any point. Suppose I am considering this point, this value of I will be there, certain value of V will be there. So V into I will be definitely positive. And here also this is a negative I, negative V, and this is a negative I. So negative into negative will be again positive. So the product of voltage and current will be, I mean, here in the graph will be positive always. So we can say that it is passive. So positive for passive, that is the trick to but remember, positive for passive. And let's see, it is unilateral or bilateral. That is very important. So for bilateral circuit, the trick to find bilateral circuit is from the graph. If the graph is similar in opposite quadrant, that is a condition for bilateral. In here we can see this same graph. I mean, this same graph is a duplicate of this portion is this portion. So in opposite quadrant, that is, this is the first quadrant, and this is second, and this is third quadrant. So in 1 and 3, the graphs look similar. That means in opposite quadrant, if the graphs look similar in same manner, then we can say it is bilateral. And let's see another linear, and let's see linear or non-linear. The condition for linear is it should pass through, there are two conditions actually. First condition is it should pass through origin. And the graph will be, I mean, the connection relationship will be linear. I mean straight line. Or in other words, clear manner we can say that the slope will be constant. Very, very interesting. This is actually exact word. The slope will be constant. So by looking these two conditions, only we can say that the given element is linear or non-linear. We have to check the graph is passing through the origin, and we have to select the slope is a constant. So let's see for this element. So of course the graph is passing through the origin. So first criteria is satisfied, and second criteria is what? Slope will be constant. See, this is the slope. Slope is nothing but what? Y by x. I mean, this is a slope. Suppose this is a theta, and this will be a y term, and this will be x term. So definitely tan theta slope m will be equal to what? Tan theta equal to y by x. So this is the slope for this portion, and similar slope will be obtained here also, which means the slope is same. Or slanting is same. So we can say the second condition also satisfied. So this is a linear element. Clear? So we can say that the given element is linear. And this is how we have to check all this: active or passive, unilateral or bilateral, linear or non-linear. Let's take another example. Consider a graph like this. This is V and this is I. Consider a graph like this. And let's again we have to check what unilateral or bilateral, linear or non-linear, and active or passive. We have to see these three. Let's check one by one. First of all, a unilateral or bilateral. What was the trick to find whether it is unilateral or bilateral? For bilateral circuit, what I said, in opposite quadrant the graphs look similar, then only we can say that it is bilateral. In opposite quadrant, this is first quadrant and this is third quadrant, the graphs exactly look similar, right? The graphs exactly look similar. So we can say that I mean in first quadrant it is directly the mirror image of second quadrant, third quadrant. That is the concept. Opposite quadrant the graphs look similar means the one for quadrant 1 and quadrant 3 the graph should be mirror image to each other. So clearly it is visible from here that exact copy of first quadrant is in third quadrant. So we can say that it is bilateral. And let's see whether it is linear or non-linear. I said two conditions for linearity. What is that? First of all, we have to the graph should pass through origin. Here the graph is passing through origin. First condition satisfied. And what is the next condition? And the graph should be passing through origin and the slope will be constant. That is very, very, very important. That is very, very important. See, here it is in certain slope, but after that the slope is changing. Here it is in certain slope, after that the slope is changing. So in first quadrant as well as in third quadrant the slopes are not constant. The slope is varying. So the second criteria for linearity is not here. It is not satisfying. So we can say that it is, of course it is non-linear. Of course it is non-linear. So it is very important because by simply looking we feel that it is something like linear, no? Linear, no? Because it is linear and straight line is also linear, no? So it may be linear. We can doubt in that way. But this is actual case. This is the non-linear. And let's see next, active or passive term. How can we check? I already explained how can we check active or passive. The product of V and I again, no? The V and I. The product will be what? Of course positive. Again V and I. So V and I. Any value at any point in the graph, the product of corresponding current and corresponding voltage will be what? Will be positive. Any value you can say, you can take this value, you can take this value, any value you can, or you can take this value. Any value, the product of V into I will be positive for passive. So this is of course passive. Clear? And let's see another example also. Because in examination many cases may be given. Okay, many cases may be given. We have to clearly identify. Another example, you can see another example. And this is the graph of certain element, say element Y or element Z. Then we have to again check for unilateral or bilateral, linear or non-linear, and again active or passive. Let's see what are first unilateral or bilateral. So for bilateral, I said what was the condition for bilateral? For bilateral, in opposite quadrant, the graph should look similar. The graph should look similar. But here, see, in first quadrant there is a portion of graph, but in the third quadrant there is no graphs and all. That is, there is no relation and all. So these and these will not be similar, look similar, or we can't say that this will not be the mirror image of quadrant 3. So this is of course the condition for unilateral. It is not bilateral. And check linear or non-linearity first. For linearity I already said it should be passing through the origin. Of course it connecting to origin now. It is passing through the origin now. It is passing through the origin. So first condition satisfied already. And what is the second condition for linearity? And the slope will be constant. Very, very important here. Slope will be constant. Definitely some students will feel it is, I mean, there will be confusion. Let's see. Let's see the second condition, the slope will be constant. See this portion, the slope is a positive one, and see this portion, the slope is a negative one. I mean, it is increasing and it is decreasing. So here the slope is positive and here the slope is negative. Even though the magnitude may be same, but the direction, I mean the exact slope is different actually. It is a positive slope and this is a negative slope. So we can't say that the given element, I mean graph, is linear, because it violates the second criteria. I mean, what is the slope should be same. The slope is not same here. The slope is different. It is for positive slope and this is a negative slope. So we can't say that the graph looks same slope all the time. So it is non-linear. It is non-linear. And let's see active or passive condition. What is that? I already said the product of V and I at any point, at all point or any point, will be equal to positive for passive and negative for active. So let's see. Suppose I am considering this point. For this point, the voltage is a positive and the current is a positive. So the product will be what? Of course positive. But consider this point. What is that? The current will be negative, but the voltage is positive. So what will be the product P? I mean power P, V into I. What is will be V? A positive value into negative value. So V into I, the product of V into I will be equal to what? Negative. Will be equal to negative. So negative for active. Negative for active element. So this is how we have to check, or we have to examine that whether the given element's graph is linear, non-linear, active or passive, unilateral or bilateral. Clear?